right, so today's an exciting day because now we're going to keep talking about derivatives, but we're going to kind of limit how often we have to use that limit definition of the derivative and make our lives a whole lot simpler. So over the 2 videos, we're going to look at different rules to help us simplify derivatives. And like I just said, using the limit definition, it's very time consuming. There's a lot of mistakes you can make along the way because there's a lot of algebra. All right, so we're going to figure out a way to simplify the process. And the first rule of derivatives is called the power rule. So we haven't probably mentioned this notation yet, but when you see this d dx with something in parentheses, this means take the derivative of that. All right, so d dx, take the derivative of that thing. All right, so when you see that little d dx by itself, it means take the derivative of it. So if I take the derivative of x to the n, all right, I'm starting with x to the n, what's going to happen is this n exponent is going to jump down in front of my x, and then I subtract 1 from the exponent. So n to the x to the n, or sorry, n times x to the n minus 1. All right, so the power rule is going to be our most straightforward rule for taking derivatives. All right, whenever we just have a power of x, we just bring that n down and subtract 1. All right, so doing some examples, f of x equals x to the 4th, f prime of x. The 4 is going to come in front of the x, and then we subtract 1 from the exponent. So 4 minus 1 is 3. All right, and that's all we have to do now. We don't have to go through and FOIL out a big expression and everything. All right, we just know the derivative now of f of x equals x to the 4th is 4x cubed. At this one, really similar. If f of x equals x to the 9th, f prime of x is going to be 9x to the 8th. All right, the 9 comes down in front, and 9 minus 1 is 8. All right, and here's where you have to use some other information to help us use the power rule. All right, so if you just look at this one, it doesn't look like a function where we can use the power rule. But if I rewrite f of x, the square root of x, we mentioned in the review of logarithms and exponentials, the square root is the same as the 1/2 power. Right. So what I can do now is use my power rule, which says I bring down the 1/2 to the front, and then my exponent becomes 1/2 minus 1, which is the negative 1/2. All right, so we could leave it like that. We could also rewrite it as 1 over 2 to the square root of x. You can write it a bunch of different ways, but the main thing is rewrite this as a power of x, and then you can use the power rule the exact same way we did in the previous examples. All right, same thing with this one. All right, at first you might try to do this. All right, but this fraction bar means I can't just use the power rule right away, right? Because that's not the way the power rule is set up. The power rule doesn't have this fraction in it, so I need to change this first so I can use the power rule. And the way I do that is, again, using exponent rules, is if I have an exponent on the bottom, I can move it to the top of a fraction by just making the exponent negative. So x to the negative 2 is the same as 1 over x squared. And then I can use my power rule, negative 2, x negative 2 minus 1 is negative 3. And you can keep it like that, or you could write it like that. All right, so the main thing right now, the power rule is our main rule. We'll learn some in another unit. But right now, if you can rewrite your expression with a power of x, then you can use this power rule, bring down the exponent, then subtract 1 from the exponent, and then you're done.